All right, so let's now look at some more examples of finding a confidence interval to estimate a proportion. So we are now at a formal example 1 here. And in this particular example, I will be going through quite a few different questions. So question in part A of example 1. In a sample of 377 cell phone users, 285 of them are iPhone users. Estimate the true proportion of iPhone users using an 80% confidence interval. So once again, as we already have seen a lot of explanations throughout the beginning lecture about confidence interval, how to find a confidence interval to estimate a population proportion, then in here we can see that according to a given information, the confidence level that we are given here, lowercase letter c, is given to be 80%, or for calculation we use as a 0.8. According to this given information, it's a 80% confidence interval that we are constructing, that we are finding. So confidence level here is 0.8. The next piece of information, right from the beginning, in a sample of 377 cell phone users, and among those cell phone users, we found the count here is 285 of them are iPhone users. So it looks like in particular we're looking for that category for being the iPhone user among all cell phone users. And assumingly in these days, everybody is using a cell phone of some kind. There are Samsung users, there are Nokia, and there are iPhones. So we would like to find out what is the proportion of, we would like to estimate the true proportion of iPhone users, not only in the US, not only in China. I'm looking at the proportion globally, the global proportion of iPhone users. And so what we have here is only a sample in 377 of cell phone users globally. We found 285 of them are iPhone users. And so that proportion here that we have, 285 over 377, this is regarded as a p hat, and in decimal and in 4 decimal places, the decimal of this proportion is 0.756 in 4 decimals, or this is about a 75.6% here. But this is only a sample proportion, so I have to remind everybody that. And of course, extracting the information from this sample, the sample size here is, of course, 377. And that is everything we need right here. So that is the given information. And so the proportion here is and notice that in my wording of the problem on the computer screen, I refer to that as the true proportion of iPhone users, meaning here is only in a sample of 377, but really throughout the entire population of cell phone users out there, what is the proportion of iPhone users? So this true proportion, or in other words, the population proportion, is unknown. And that is the population parameter to be estimated, and P here is the population proportion of iPhone users. Throughout the video giving lecture, the complete lecture on finding confidence interval to estimate a population proportion, then I had to give a lot of explanations. So it took quite some time to get one problem done. But in this video, things are going to pick up pace a little bit. But so ultimately, we understand that our confidence interval is expected to be from where our sample proportion currently is. We simply need to figure out a margin of error up and down from where our sample proportion is. And that's the goal of the problem. And so sample proportion, we already had the value being 0.7560 and need to be up and down by a margin of error. And so now margin of error, according to the formula, we are going to multiply the value of z sub c to a square root expression, which has p hat times 1 minus p hat divided by the sample size. So that's another reminder about the formula. And so here, what we're looking at is the z sub c value multiplied with the square root expression, and inside of that it has so 0.7560 here multiplied with the expression 1 minus 0.7560, and all of that divided by our sample size being 377. And so we're once again almost complete with that formula to calculate margin of error. So what we're currently waiting for is a value for z sub c. And so now once again, that's a little bit of side note here, but for z sub c, let's calculate z sub c a little more separately right here. So z sub c, after reviewing the video on the complete lecture, and here's how we're finding it again. We're going to go first step here is 0.5 add with half of our confidence level. So confidence level being 0.8, but we're adding half of that, 2.5. And so this value calculation comes out to be 0.9. And this value is being referred to as an area left, or left area. An area left here, I mean area left of that particular z score, z sub c value that we're looking for. And so now z sub c can simply be found easily at this point by running the INV Z program. And I also gave a lot of detailed explanation about the INV Z program in earlier video lectures. The amount of area this time I am going to provide 0.9 as left area for that. Alright, and with my INVZ program just now being executed on screen here, then the answer back on my writing board, the answer for z sub c comes out to be, so this is the box where it's indicating our final values for z sub c. And on a TI 83 or 84 calculator, we find the command equivalent to the INVZ command by accessing second variables. And the equivalent command is indeed called INV norm in the TI 83 or 84 calculator. Hit enter. Now on the TI 83 calculator specifically, after we select INV norm, the command, instead of showing a menu as you have seen earlier, will be printed directly on your home screen. And so now let's continue running our INV norm command on a TI 83 or 84 calculator. So when you have a menu like this, we're going to enter 0.9 for our area. And we are going to default 0 for mu and 1 for sigma. This is because we will always be working on the standard normal distribution. We can hit enter a few times and end up with the completed command being printed on our home screen here. And it would be the same if you are running on a TI 83 calculator. You must enter manually these values separated by commas and close the parentheses. And once we have completed our command, now we can go ahead and hit enter. and this is the z sub c value, which agrees precisely with the value we've seen calculated by the INVZ command program on Microsoft Excel. So in 3 decimals, 1.282, and that is our z sub c. And so now, after having z sub c calculated, then our margin of error formula is ready to proceed. Margin of error equals the z sub c we just now found, 1.282, multiplied with square root of 0.7560 times another expression in parentheses, 1 minus 0.7560, and divided by sample size 377. And I remind everybody, anyone who views this video, that this formula for calculation, make sure to follow the order of operations. So now, final calculation comes out to be 0.0284. So that now means back to our ultimate goal of finding the confidence interval. Our final confidence interval is going to be as following. From where our sample proportion is, being 0.7560, the actual proportion of iPhone users, the actual population, the value of the population proportion of iPhone users is anywhere from this sample proportion 0.7560 and up and down by another additional 0.0284. So anywhere 0.0284 up and down from our sample proportion 0.7560. That is the interval that at 80% successful rate, the actual proportion, population proportion here will fall inside of that interval. And this interval right here, as I said in my complete lecture of how to find a confidence interval previously, but this interval, this style of writing the interval is common among the statisticians. But another way of writing that is we can subtract this value from the center point to have low end, and we can also add this value to the sample point, to the center value, to the middle value to get the high end, and to bring our interval into the traditional format showing low and high. So the low of this interval will be 0.7276, and the high of the same interval is going to be 0.7844 after calculation. And so this interval showing low and high, a lot of times I refer to this as the interval in traditional formats, meaning it shows low and high. So it's the interval in traditional formats. All right, so now same example, but we're now in part B, or question B. So by far you can see that in this example 1, there hasn't been a beginning description or anything like that. Each question in the example 1 right here is one question on its own and having its own description. So here, in a sample of 377 cell phone users, 285 of them are iPhone users. Let's now estimate the true proportion of iPhone users by using a 95% confidence interval. So once again, let's list down the given information. So this time I am going to list down the given information according to the order of how the problem was written. So in a sample of 377 cell phone users, 285 of them are iPhone users. So this beginning description is now telling us that we have a sample proportion value 285 over 377. And now we actually realize that this is the exact same sample proportion we had in our part A previously. The decimal value comes out in 4 decimal places to be 0.7560. And the sample size from this sample is 377. Confidence level in this case right here. So now let's look at the very ending part of the problem here. But the problem is asking us estimate the true proportion of iPhone users using a 95% confidence interval. So this final piece of information right here is indicating that we are given with a confidence level being 95%. So lowercase c equals 95. But for calculation, we will be using this percentage as in decimal. So 0.95 is our confidence level. And so, of course, the true proportion of iPhone users that we are estimating right now, once again, P is unknown. It's the unknown population proportion. And what does P mean? It means P means the population. Proportion of iPhone users. And so now we can even pick up even faster pace right here. But so confidence interval is constantly that goal from where our current sample proportions. We are going to find out how much up and down the interval, this interval at 95% confidence level can be. That means eventually we're going to have to look at 0.7560 to be our sample point and to be the center of our interval, to be the midpoint of our interval, and then we're going to figure out the margin of error up and down, including the very beginning example I made in my complete lecture on how to find confidence interval for a proportion. Then this truly is our third example where we're doing some actual calculation. And so allow me to change the order of the steps a little bit. But how about eventually we're going to need a z sub c. So let's quickly find a z sub c. 0.5 plus 0.95 over 2 this time. So 0.5 plus half confidence level. And this is in decimal 0.975 according to the calculation. Then z sub c comes out by running the INVZ. Given that left area or area left of this z sub c is going to be 0.975 that we're going to provide for the INVZ program. So as far as the steps, how to get it done, these are the basic steps right there. So on my screen with the INVZ program here, then with the left area being 0.975, the z sub c comes out, the z score comes out from that is 1.95 and 996, and a lot longer. And now on a TI 83 or 84 calculator, we go second variables, INV norm. Again, this is the command equivalent to the INVZ command. We hit enter. So the more advanced TI-84 gives this menu right here so that we can enter our area value and later on execute the command. Whereas on a TI or any TI-83 calculator, we will have the command directly printed in on the home screen with an empty parentheses here ready for us to type in the area and the mean and the standard deviation of the bell curve. So now we are going to enter the amount of area. So 0.975, and the bell curve we're using here is defaulted to the standard normal distribution bell curve. So 0 for mu and 1 for sigma. So I'm going to hit enter a couple of times. And so on the TI-83 calculator, we will have to enter all of these values manually, separated by the comma, in this order. And now on any TI calculator, we're going to hit enter. And this is our z sub c value, which agrees with what we saw earlier using the invz command that was programmed with Microsoft Excel. And so I only need 3 decimals here. So that means my final z sub c is concluded to be 1.96. So I meant to round the final z sub c in 3 decimals, but in this case of having our z sub c coming out on the computer screen just like how you saw earlier, then the only choice we can end up is the z-score with 2 decimal places. And now once we've had z sub c, margin of error is ready. Once again, from where the z sub c we have found, we're going to multiply with a square root expression. Inside of the square root, we're going to utilize our given p hat, multiply that with a 1 minus p hat, divided by the sample size. So all of these information are already available. So we're now just simply plugging things in. So 1.96 is our z sub c. I'm going to multiply with a square root expression. So this inside of the square root expression, it contains this calculation right here, 0.756 in times in parentheses 1 minus 0.756. I am going to divide by the sample size 377, and remind yourself that make sure this expression inside the square root is being computed before you're taking the square root, and then after taking square roots, then we are going to multiply with that z sub c in front. So now final calculation comes out to be 0.0434, and that means our final confidence interval is concluded to be from where our sample proportion currently is 0.7560. The actual population proportion of iPhone users, and here I'm talking about the actual global population proportion of iPhone users, is anywhere up and down by 0.0434 from our current sample proportion. So 0.7560 up and down by 0.0434. And this interval is guaranteed at successful level 0.95 or 95%. And in traditional format that shows low and high, our interval here has low end being 0.7126, which came out from subtracting 0.0434 from 0.756. And the high end of this interval is 0.7994, where this value came out from adding this margin of error to the sample value in the middle. So once again, I call this the traditional formats of the interval. All right, so now in another question of example 1, and this time after doing quite a few times repeatedly with this skill on finding a confidence interval to estimate a population proportion value, and I am really going to pick up the pace here. In words, the question is stating that in a sample of 399 cell phone users, 300 of them are iPhone users. Let's now estimate the true proportion of iPhone users using a 95% confidence interval. Sorry that I had a little typo here, I didn't recognize that. And so, once again, as far as given information, let's list down the given information. In a sample of 399 cell phone users, 300 of them are iPhone users. So what we have now is a p-hat value, a sample proportion value, 300 out of 399, and calculation comes out in 4 decimal places. This sample proportion is 0.7519. So now we realize that this is a different sample proportion value. We have a larger sample size, being 399. And the value does change slightly a little bit. So every sample is different with any other sample. Sometimes we might be lucky and we run into 2 samples with the same sample value. Confidence level here is, this final information is telling us that we're looking at confidence level being 95%. So confidence level here is 95%, c lowercase c equals 95%, or 0.95. And of course, in this case, we're estimating the true proportion of iPhone users, which means for now the proportion, the population proportion P right here, the non-hat version, is unknown, and that's the whole point of estimating it. It's an unknown population proportion, and what it is, lowercase letter p is the population proportion of iPhone users. So same meaning, we're going to estimate the same targets here, the same value here, but using different samples. That's what my entire purpose of showing this example with different questions right here. All right, so once again, our interval, our confidence interval, ultimately is going to be from where our sample proportion currently is, which we already had, but as a new sample proportion value. But then we need to figure out how much margin of error up and down from where our p-hat value is. So another way of saying, from where our sample proportion being 0.7519, I am going to figure out a margin of error up and down from there. So now once again, I am going to jump immediately into figuring out the z sub c value, because for z sub c value, it's one critical required part in the formula. But other than that, any other values that we have seen in the formula for margin of error are already given. So z sub c here, I am going to repeat the steps. 0.5 plus half of 0.95, which is half of our confidence level. This gives me 0.975. And I regard to this as some area, as the area left to the left of this z sub c. And so our final z sub c is going to be the result of running the INVZ with the provided left area to be 0.975. And so final z sub c concluded to be 1.96. And the reason I can move on really quickly in these steps here, because if anyone is viewing the 2 videos back to back right here, then the one I've had for part B of the example, we use the exact same confidence level with the one we're looking at right now. And I purposely designed these kind of examples so that you can notice the changes to the final interval as we change a little bit of information. So z sub c is finally concluded for this problem at confidence level 95%. Z sub c is 1.96. So margin of error formula is now ready. That famous formula where z sub c is multiplied with a square root expression p hat times 1 minus p hat over n. Now with the values substituted in, z sub c is going to be substituted by 1.96. So 1.96 substituted for z sub c. And here inside of the expression, we're looking at 0.7519 multiplied with 1 minus 0.7519 and divided by the sample size is changed to something bigger than the previous questions. So 399, that stays here. But now we are ready for the final calculation. So final calculation comes out to be, in 4 decimals, 0.0424. That means our final confidence interval is from where our sample proportion value is currently. And this time in this question part C, remind yourself that I already changed to a different sample. So the sample proportion value here is 0.7519. Up and down by 0.0424, meaning the true proportion, the global population proportion of iPhone users is anywhere 0.0424 up and down from our sample proportion, currently being 0.7519. So that's our answer. And this answer, once again, in traditional format, shows low end is to be 0.095. That's the low end. And this traditional format shows the high end of the interval is 0.7943. And so I call this interval over here, this kind of interval showing low and high, this kind of format showing low and high of the interval, I call that the traditional format. And now let's look at the confidence level in problem B that we've already finished of example 1. It was 95% confidence level, or in decimal 0.95. The z sub c we came up there, the z sub c that we calculated there in part B was a 1.96. And then let's look over to question C. We stay with the same confidence level being 95%, which is in decimal again 0.95. And we came to the z sub c. I repeated the steps, and I came to the z sub c being 1.96 again, and I meant exact value, exactly equal. And so it's easy to understand this, because now if we look back at the general steps how to find the z sub c, let's look back at the steps of how to find the value of z sub c. The first big step is to run calculation 0.5 plus c over 2. And whatever comes out from this expression is being regarded as the area left. And then we would provide this amount of area left into our INVZ program, which runs in the next step, step number 2. And so that means, and then once we finish running step 2 right here, then we come out with our z sub c. So the entire picture showing the steps here is indeed indicating that finding z sub c value is only dependent on your c value, on your confidence level value. So it makes sense perfectly now that as long as you stay in the same confidence level, then this z sub c will come out exactly the same. Why do I need to mention this to anyone who views this video? because now from now on, this is for the rest of the video lectures here. Anytime going through the Z sub C, I'm still gonna repeat these steps right here. But I'm talking about when you're actually doing the work on your own, you can speed up the process a little bit that by skipping all these steps here if you can recognize some confidence interval you have used already. So no need, basically my point is no need to repeat Z sub C calculation, okay, for the same confidence level. So anytime that you already calculated through the steps the Z sub C for some confidence level, and if you're running into that same confidence level again, maybe a couple months later, you run into another problem where it brings up another another confidence interval problem with the same confidence level, then you can legally use that and officially use that same Z sub C that you calculated, provided if you still remember it. Okay, and so that's how you can save yourself some effort sometimes when doing this kind of work.